So today's lesson is on properties of triangles. So the first triangle we're going to look at is up here. And we're going to first talk about the sides of the triangle. This triangle in particular has sides of 3, 4, and 5. Okay. When we know that there is 3 different sides, and meaning none of them are equal, we call this a scalene triangle. One of the other things we also need to look at too is this triangle possible with the sides? Does it work? The way that we can do this is we can actually take 2 of the sides, and we're going to go ahead and see if these 2 sides, when we add them together, are greater than the third side. So I'm always going to take the lesser side. So 3 and 4, when we add those together, is equal to 7. And then 7 is greater than 5. Okay? And I'm going to go ahead and use that to compare the rest of them as well. So let's go ahead and do this one. Next one, we have 3 sides that are all the same. We call that an equilateral triangle. Okay. We call it an equilateral triangle because the sides are equal. That's where that equilateral comes from. Okay, and so let's do our side test now. We can do 8 plus 8 equals to 16, and that is greater than our 8. Okay. And my last one is 2 sides of 6 and 6 and 11. A triangle that has 2 sides that are equal to each other, we call that an isosceles triangle. And if I add up my 2 lower sides, 6 plus 6, it's equal to 12, and that is greater than 11. Okay? So that actually helps us fill in our triangle inequality theorem. Okay, the triangle inequality theorem is that the sum of any 2 sides of a triangle must be greater than the third side. And we can see our examples up here, all of this was true. And even with the scaling, we can do that as well. Besides just doing 3 plus 4, we could also do 3 plus 5 is equal to 8. And that's greater than 4, the remaining side. We could also do 4 plus 5 is equal to 9, and that is greater than 3, the other remaining side. Okay. Equilateral one is the same for all of them. And then if we want to do the isosceles one, if we want to do 6 plus 11, add these 2 sides up, it's equal to 17, which is greater than 6. So all these triangles do work, and you can do the triangle inequality theorem to make sure. Okay. Now let's go ahead and look at the angles. Okay. Whenever we have a triangle, the sum of the interior angles of a triangle always have to add up to 180 degrees. That's our rule. That's our triangle sum theorem. Okay. So we can check that by doing 60 degrees plus 30 degrees plus 90 degrees, and yes, it does equal 180 degrees. Okay. This triangle right here, we call this a right triangle because one of the angles is a right angle. Alright, the next one we have, let's check and see if it adds up to 180. 60 plus 60 plus 60. And we have 180. Okay. So it does work. In any triangle we have where all the angles are less than 90 degrees, we call it an acute triangle. Also known as an equilateral triangle is always going to be an acute triangle. Alright, for our isosceles triangle here, let's go ahead and add them up. We have 25 degrees, 25 degrees, and 130. 25 plus 25 is 50. Add that up, and yes, we get 180, so that does work. And then we're going to name this one an obtuse triangle. Okay? Because it contains one obtuse angle, that being our 130 degree angle. Okay? So those are our types of triangles. You can describe them by the sides as well as the angles, and those would be how we would describe them. Okay. So let's go ahead and do this to practice. Slide this up. So determine if you make a triangle given the dimensions, state why or why not. So we're going to decide if a certain one of these is a triangle. So our first one is sides of 4, 6, and 7. So I'm going to go ahead and do my triangle inequality theorem to check it. So I'm going to check the sum of any 2 sides, that they're greater. And I'm just going to take the smallest 2 sides. So I would do 4 plus 6. 4 plus 6 is equal to 10, and that is, my last side is 7, and so it's greater than that, so yes, it does work. Then I'm going to use my triangle sum theorem here with my angles to figure out if my angles work. In this case, I have 30 degrees plus 60 plus 90. If I go ahead and add those up, 30 plus 60 is 90, plus another 90 is 180. So yes, that does work out for those two. Alright, number 2, my sides measure 5, 3, 10. So let's go ahead and take my two smallest. I'm going to add up my 5 plus 3, and that equals 8. And how does that compare to my 10? Actually, my 10 is greater. So that already looks like it doesn't work, but let's check the angles too as well. 35 plus 65 plus 80. Add those up, and I get 180. So my angles do work here, but my sides do not in this case. So I'm going to put no and draw an arrow over there. Okay. And the reason this doesn't work too is if you think about one of the sides being, say, 10 centimeters long, okay? Say that's 10. If you put together the two other sides, say you put together the 5, it's about half of it, and then go to like about 3 more, you can't even put two sides together to make that 10, so how could they actually be angled as well? So that's why that doesn't work. And then number 3, we have side measurements of 14, 6, 9. Let's take the lower 2. 6 plus 9 is equal to 15. And that is greater than my remaining side of 14, so that checks out. And let's check on my angles here. 25 plus 75 plus 90. That actually equals 190 degrees. So no, that doesn't check out because the angles are wrong. Alright, and then my last part here, we're going to classify each of our triangles by its sides and our angles. So number 1 here, looks like if we look at the sides, we have 3 sides that are all the same. So it is a equilateral. And then if I look at all my angles, they're all less than 90 degrees, so it's an equilateral acute triangle. Number 2, go ahead and look at my sides here. I have 3 different sides, so I know that is a scalene triangle. And then if I look at my angles, I have one angle that's greater than 90 degrees, so I know that it's an obtuse triangle. So it's a scalene obtuse. And then lastly, look at this one. I have 2 sides that are 7 and one that's 10, so when 2 sides are the same, it is an isosceles triangle. And then if I look at my angles, I have one that is a right angle, so it's a isosceles right triangle. Go ahead and pause your video right now. And you guys can go ahead and try yours. And when you get done with trying all of them, you guys have 3 where you're using the sides and 3 where you're using the angles, and then you have to classify your triangles as well. So when you're done with those, you may check how you did. So my first one, we said no, you cannot have this be a triangle because our measurement is together is 190 degrees. So that's incorrect. The sides were okay, but the angles weren't. Number 2, we said yes for both because the sides were okay and the angles measured up to be 180 degrees. Number 3, we said no because 2 of the smallest sides only added up to be 10, and 2 sides always have to be greater than one side. But it does add up to 180 degrees, but we still said no on that one. And then for our triangles here, first one was an equilateral acute. All the same sides are equal, and then all the angles are less than 90 degrees. Number 2, we had all different length sides, as well as all the angles are under 90 degrees, so scalene acute. Number 3 was isosceles because we have 2 equal sides, and then obtuse because it's one angle greater than 90 degrees. That's my 128. And I have number 4, we have an isosceles right. Isosceles because we have 2 equal sides, and right because we have our one right angle there. Number 5 was isosceles because we have 2 4.8s, 2 equal sides. and then acute because none of the angles measure over 90 degrees. And number 6 is scalene because we have different length sides, and then it is a right triangle because we have one right angle. So that's how we classify our triangles using their angles and their sides.